Here we are asked to find the general solution to a linear first-order differential equation. We have listed the 4 key steps on the side. Let's begin with step 1, which tells us to write the equation in the standard form. And if we look at the standard form, we can see that we need a dy dx, which we have right here. We then need to have a term in which a function of x is being multiplied by y. And that's actually our term right here. In this case, the function of x that's being multiplied by y is actually just a -1. And then on the other side of the equation in standard form, we have to have another function of x. And in this case, what we can do is add this e to the 3x to both sides of the differential equation. This will actually finish off putting this in standard form. We now have dy dx minus 1y, and then this will equal e to the 3x. Now, if you prefer, you can rewrite that as dy dx plus -1y equals e to the 3x, because by doing that, that will perhaps more clearly show us that the p of x, which is just a function of x that's multiplied by y, would again be -1. So we can actually write down that our p of x is equal to -1. And that's useful because in the second step, we have to figure out the so-called integrating factor, mu of x. And mu of x is going to be e raised to the power of the integral of our p of x function. So in the second step, we can say that our integrating factor, mu of x, is equal to e raised to the integral of our p of x, which again is just -1, and then dx. Now what you need to do is figure out what this integral equals, of course. And of course, the integral of -1 dx is just -x. So that means our integrating factor is equal to e to the -x. So there is our integrating factor. That completes step 2. In step 3, we have to multiply the differential equation in standard form by the integrating factor. So let's go ahead and take our differential equation. Let's multiply both sides of it by our integrating factor, so e to the -x, like that. And then it says to recall that the left-hand side is just the derivative with respect to x of the integrating factor times y. So what you'll always do in this process is rewrite this left side as the derivative of your integrating factor, which was e to the -x, and then times y. And then this will be done with respect to x. On the other side, you can simplify because you're multiplying two exponential functions, so we're going to add those powers together. If we add those together, we get 2x, so we're going to have this equal e to the 2x. So that would complete the third step. The fourth step is to integrate this last equation and then solve for y. And so, if we integrate both sides of this equation, basically you're integrating with respect to x, what happens is the integral and the derivative effectively cancel one another out. And so you end up with e to the -x times y. On the other side, we have to integrate e to the 2x with respect to x. Recall that the integral of e to the kx, where k is a constant, is equal simply to 1 over k e to the kx. So then this side becomes 1/2 e to the 2x. And then don't forget that you have to include this constant of integration, capital C. And then we still have to solve for y. And the best way to do that perhaps is to multiply both sides by e to the positive x. And we're going to see why this works really nicely for us in just a moment. And it works because e to the x times e to the -x would require us to add those exponents again. And if you add those exponents, you get 0. So basically you have e to the 0 times y. But of course e to the 0 is just 1. So 1 times y becomes just y. So we've solved it for y. We have y is equal to this expression here. Why don't we go ahead and just distribute the e to the x. So we would have 1/2 e. Now you're going to be careful here again. You're multiplying e to the 2x by e to the x. That becomes e to the 3x because you're adding the powers, plus the constant of integration times e to the x. And so this would be the general solution to that linear first-order differential equation. Thanks for taking the time to watch the video. If you're interested in making a small donation to my cause, I'd greatly appreciate it. But no problem if not. I appreciate you taking the time to watch the videos regardless.